let's take a look at solving the system of three equations by any algebraic method. So we have a system of three equations, three variables, and we're trying to solve the order pair where they all cross each other. For this one, the best way to solve it is to reduce it to a system of two equations. So that means we're going to get rid of one of the variables. First of all, I like to start by labeling my equations. So this is equation 1, equation 2, and equation 3. Just because it's going to make it easier to keep track of all of them. When I take a look at all of my equations here, and this is like number 41 of your review. When I take a look at here, and my goal is to get rid of one of the variables, right? If you look at equation 1 and you look at equation 2, we have negative z and positive of it. So if we were to add them together, it will automatically get rid of one of the variables. So I'm going to take equation 1 and I'm going to add equation 2. So I'm going to take equation 1 and equation 2 and add them together. So we have x minus 2y minus z equals negative 6, 2x minus y plus z equals 3. We're going to add them together. So I have x plus 2x, we end up with 3x, negative 2y minus y, negative y, and this one's add up to 0. And I have negative 6 plus 3, so it's negative 3. Because I decided to get rid of z, well, in this case, it was easier for me to get rid of z, that means I have to use the next equation, and I also have to get rid of z. This is a new equation. I'm going to name it equation 4. So now I'm going to somehow, I need to get rid of z from using equation 2 and 3. So I have negative 2z's, and here I have a positive 1, so I somehow have to match them, so I need a 2 in here. So I'm going to take equation 2 and multiply it by 2, and then I'm going to add it with equation 3. So that means everything in equation 2 gets multiplied by 2. So 2x times 2 will give us 4x. Negative y times 2 will give us negative 2y, and here will give us 2 times z is the 2z. 2 times 3 will give us 6, and I'm not doing anything to equation 3, I'm just copying it down. Now you can see when we add them together, they're going to cancel out, which is what we were looking for. So I have 4x minus x, we end up with 3x. We have negative 2y plus y, which is negative 1y, equals 6 plus negative 5, which is positive 1. And we have created a new equation. I'm going to name it equation 5. Now look at this one. Our new equations have the variables x and y. They no longer have the variable z. So now we have two equations, two variables. We can use any of the methods we previously learned to be able to solve this one. So we have created a new system. We have created the system 3x minus 3y equals negative 3, and 3x minus y equals positive 1. So for this one, you can use substitution method, you can use addition method, you can use Cramer's rule, you can use matrices, whichever one you like. I like to stick with addition or substitution method. So in this case, I'm going to go ahead and use addition method, and let me tell you the reason why, because you can see here I already have a positive 3x and a positive 3x. So I can get one of those to become negative by multiplying by negative 1. So you can take either one. I'm going to take this first one, and I'm going to multiply it by negative 1. So everything gets multiplied by negative 1. So I get negative 3x positive 3y equals positive 3. I'm not going to change my second one. So I'm just left with 3x minus y equals 1. And I'm using addition method. So once I get one of them to match by multiplying by a non-zero number, I go ahead and add them together. So they add up to 0, which is what we were looking for. Positive 3y minus y, we end up with 2y equals 3 plus 1 is 4. Look what happened here. Now we're only left with the variable of y, so we're able to solve for y. So we found out the y is equals to 2. This piece of information, we're going to take it and use it either in equation 4 and 5 to be able to solve for x. So I'm going to go ahead and take equation 5. So I have 3x and we found y to be 2. So now I'm able to solve for x. So I add 2. So I end up with 3x equals 3. Divide by 3, so I find that x is equal to 1. Now that we solve for x and y, now you go back to the original system of equations to be able to solve for your z. So I'm going to go ahead and pick equation 2 because there's already positive z here. So I'm going to take 2. I'm using equation 2. 2, we found x to be 1. Minus y, we found y to be 2, plus z equals 3. And now I'm able to solve for the third variable. So I end up with 2 times 1 is 2, minus 2 is 0, so I get z equals 3. So that means the solution is x is 1, comma, y is 2, comma, z is 3. So the triple point here is 1, 2, 3.